So welcome back. We'll take a look at CR6 here, rational expressions and reducing to lowest terms. And what I like to do is, it's kind of like with rational numbers. You know, if you take 7/5, reduce it to its prime number. 7 and 5 are both prime numbers. But let's go ahead and take the 10, which is 2 and 5, right? So this is all 7 times 2 times 5, 5 times 49, 7 and 7. Then we could just cancel. The 7's cancel. 5 over 5 is 1. So it looks like we're just left with 2 7s. So our reduction there becomes 2 7s. If we're dividing a rational number by another rational number vertically, keep change flip, we're going to multiply by the reciprocal 14/5. If I do it to the bottom, I got to do it to the top, because 14/5 over 14/5 is 1. So this just leaves us with 5 halves times 14 over 5. And let's go ahead and factor the 14. 2 and 7, and the 5, of course, is 5. So 5 over 5 cancels. 2 over 2 cancels. Looks like we're left with just a 7 on this one. I want you guys to do that next one and go ahead and type that in your solution on that one. Make sure you check your work on that one. Then let's move on. What about if we have a rational expression? In other words, a polynomial over another polynomial. On the bottom here is just a polynomial of a constant 10. But what we're going to do is we're going to go ahead and we're going to factor the 5x minus 20. So I'll factor a 5 out. I'm left with x minus 4. And factor a 10 out. Well, that's the same as 10, of course, is 5 times 2. See how the 5's cancel? So we've got x minus 4 all over 2. Well, you guys do that next one. Punch it into the chat there. Check your work on that one. Should end up with x plus 3. Quantity x plus 3 all over 4. Now this one here, we've got an x squared minus 12x. So I'm going to take an x out. So I can take out of those. I can take a 4 out at the bottom. And now notice I have, both of them have a factor of x minus 12. So that whole factor cancels. So I'm just left with x over 4. That's what I'm left with there. I want you guys to go ahead and try this next one. See what you get. So if you want to check your work there, should end up with, once you factor a 3 out of the top and an x out of the bottom, the x plus 9's cancel, left with 3 over x. All right, this next one, we've got a 9 that we can factor out of the numerator. And notice the bottom is difference of squares, x squared minus 49. That factors into x minus 7, x plus 7. Of course, if we FOIL that back, you'll notice you'll get x squared minus 49. And then the x plus 7's cancel. So I'm just left with 9 over x minus 7 on this one here. Why don't you guys try that next one similarly? Oh, go ahead. Check your work there on that. Make sure your x minus 12 should cancel. Now this one we've got x squared plus 6x minus 16. So let's go ahead and factor the numerator. So I know it's x and x. I'm looking for factors of 16. One's got to be positive, one's got to be negative, and their difference got to be 6. So I'm going to pick 8 and 2, because I know if I plug in a plus and a minus here, that'll work out. Notice that if I multiply that back, I'll get the x squared plus 6x minus 16. So there it is, factored correctly. My denominator is x plus 8. So if you notice, you can put parentheses around that if you want to, so you can see that those x minus 8's do cancel. And so you're just left with x minus 2. Why don't you try that next one? See how you do. All right, check that one on that you try it problem. Make sure you factor that correct. Pause it if you need to. Let's move on to this next one. If you notice on this next one, x squared plus 4x minus 21, we can factor this into x plus 7 and x minus 3. And on the bottom we have 3 minus x, right? So now x minus 3 and 3 minus x is very close. So what I'm going to do is Let me rewrite my top. I'm going to take a negative out of each of these in the denominator. So that would become negative 3 plus x. In other words, let me rewrite it. Instead of negative 3 plus x, let me write that as x minus 3. So see how I forced that by taking a negative out of the denominator? I forced those, or I can see that I can cancel those because they just differ by a negative value. So now I have x plus 7 all over a negative 1, and I'm just going to take that negative up top. You know, it's kind of like 7 over negative 1 is just negative 7. You take it up, right? So it's negative x, distribute that, minus 7. And we're all done with that one. So why don't you guys try that one right there? X squared plus 2x minus 63 over 7 minus x, similarly. Go ahead, check your work on that one. Pause it if you need to. Let's move on and reduce this next one where we've got a trinomial over another trinomial. This one will factor into the numerator. Let's see, that'd have to be plus 3 minus 10. That'll work out. The bottom denominator here, let's see, that would be plus 12 plus 3. Notice the x plus 3's cancel. So you're left with x minus 10 over x plus 12 on that one. Let's go ahead and have you guys try that one, see how you do. Should end up with that x plus 11 over x minus 8. Let's move on here to the next type. So we've got a difference of squares on the top, y squared minus 81. So that'll be y minus 9, y plus 9. Now notice in the trinomial on the bottom, I can take a 2 out first. So I'm going to take a 2 out of everything. And then I'm going to factor it. Numerator stays the same. That y squared minus 7y minus 18, well, that'll be y minus 9 and y plus 2. So notice the y minus 9's cancel. So you're just left with the y plus 9 on the top. You're left with a 2 and a y plus 2 on the bottom, and that's it for that one. So why don't you guys go ahead and try that next one. Go ahead and check your work on that one. You should have y plus 6 and a 7, y plus 1 on the bottom there. And let's go ahead and move on. This next one, I've got x squared plus 2x plus 1. So that'll be an x plus 1 and an x plus 1. And then the denominator, notice I could take an x out of each of those. And I'd have 1 minus x squared. Now, I would prefer that x squared to be first. So what I'm actually going to do is I'm going to take a negative x out instead, and that would change the signs to be negative 1 plus x squared. In other words, x squared minus 1. I did that because I know x squared minus 1 is a difference of squares. Factors into x minus 1, x plus 1. So one of these x plus 1's will now cancel, and I'm left with x plus 1 on the top, a negative x on the bottom, and x minus 1. Well, I would prefer to take that negative up top. So this actually ends up being negative x minus 1 over x, x minus 1. What I like to put in, that'll be correct. Or you could have x plus 1 over x, parentheses 1 minus x. Any of those would be proper. Now, why don't you guys try this one here. X squared plus 14x plus 49 over 49x minus x cubed. So you could have negative x minus 7 over x, x minus 7. Or another form of this would be x plus 7 over x, parentheses 7 minus x. That's another form as well. All right, let's move on here. This one's kind of tricky. Notice it's quadratic in form, and you've got these x minus 7s being squared and then another x minus 7. If I let u be x minus 7, this might make this simpler. So I'd have 3u squared plus 20u plus 12. But you got to remember you replaced x minus 7 with u. So then on the bottom I'd have 2u squared plus 5u minus 42. So then I'd factor the top. That'd be 3u and a u. And now I'm trying factors of 12. Let's see, I think 2 and 6 should work. Let me check that. 3u squared plus 18u plus 2u. There's my 20u plus 12 on the end. That works. The bottom I would then factor into 2u and a u. And now I'm trying factors of 42. Let's see, I think that'll do it. 2u squared plus 12u minus 7u. There's the 5u in the middle. Minus 42 on the end. There we go. And notice the u plus 6's cancel. So I'm left with 3u plus 2 over 2u minus 7. But remember, u is x minus 7. So what we really have is 3 parentheses x minus 7, because that's what u is. And so we have 3x minus 21 plus 2 over 2x minus 14 minus 7, which becomes, combined like terms, 3x minus 19 over 2x minus 21. Okay. Why don't you guys go ahead and try this next one similarly. See how you do. Go ahead and check your work on that. Should end up with 2x plus 1 over 2x minus 5. I let u be that x minus 1. Factor accordingly. Pause it if you need to. All right, let's go ahead and evaluate some rational expressions for x values. If x is 2, you just got to plug it in and see what you get. So we have 4 minus 32 plus 16 over 4 minus 64. Well, negative 32 plus 16 is negative 16. 4 minus 64 is negative 60. So it looks like we got negative 12 over negative 60, or 1/5. You guys can go ahead and try that one. End up with 8/3 on that when you plug negative 4 in. And let's finally talk about domain. And when we're looking at specifically rational expressions, remember we can't divide by 0. Okay, so when you're doing rational expression domains, you always want to think about what makes this 0. So what cannot be included in the domain? So let's look at this first one. I like to put in factored form the denominator. Like if you think about the denominator, I could take an x out and I'd have x squared minus 1. And x squared minus 1 factors into x minus 1, x plus 1. So if you think about it, any of these being 0 is a problem. So x being 0, x minus 1 being 0, x plus 1 being 0. Any of those are true, then we have an issue. So x can't be 1, x can't be 0, 1, or negative 1. So the domain would be all reals except for negative 1, 0, and 1. It can be anything except those values. Because again, if you throw 0 in, for example, you would have 0 times whatever. We can't divide by 0. Right? I throw a negative 1 in, again, it causes this term to be 0. Right? And so on. So let's take a look at this one. What values can this not be? So notice when I get to the bottom here, here it is all in factored form. So negative 2x can't be 0, x minus 1 can't be 0, and x plus 1 can't be 0. So in other words, when I solve these, x can't be 0, x can't be 1, and x can't be negative 1. So in this case, the domain would be all real numbers, x such that x is an element of the reals, but again, it can't be negative 1, 0, or 1 in this case. I would have to throw those out. All right, thanks so much for watching. We'll see you next time. And I should have said in interval notation, you guys, as well. Just make sure you're not including any of those, right? So you're coming from negative infinity up to -1, union -1, 0, 0 to 1. Again, you're not including -1, 0, or 1, but everything else.